Hey everyone, so in this video, we're going to talk about how to add physics and collisions to our A-frame scene. All right. So again, just to start off, to make things easy, we're going to look at some base code to start off with whenever we're doing an A-frame project with physics involved. So here's the code. It has a few new lines added to it, and you'll notice also that the A scene has an attribute called physics added to it. But just to get started, let's start at the top. So we have a physics engine actually getting added to it through a JavaScript code. And the physics engine we're choosing is ammo.js. There's a bunch more out there. I think there's cannon.js. I think there's even bullet.js maybe. But we're just going to use ammo.js for this because it's the one that's compatible with the latest version of A-frame. And again, this is just providing the backend physics for it. We still need a way to have it to interface with A-frame so that we can use it. And the next script after that, the third one, this is how we do that. So this is the A-frame physics system JavaScript code. And essentially what it does is it takes the physics and the math from ammo.js, our backend physics engine, and allows it to be used in A-frame. And the last thing here is that we have to tell our A scene what is being used for our physics. And we're basically telling it that the driver for our physics is the ammo physics engine. All right, so some simple syntax to go over. We have the ammo body attribute. And again, these are attributes that you add to any entity in your A-frame scene that you want to have physics applied to. So our ammo body is going to basically take our A entity or our A box or A sphere or whatever sort of object that we have, and it's basically going to define it as a physics body. And you'll notice that in this case, the type is set to static. I'll talk about later about what that means, but that's just a simple example of ammo body. But in order to get it to really work, to really interact with all the objects in the scene that are also ammo bodies, you need to add an ammo shape. So the ammo shape is really important because it tells A-frame the volume around your object that is the colliding volume. So whenever anything with physics as well intersects, like if one ammo shape intersects with another ammo shape, then they're going to collide or interact in some way. And you can even use JavaScript to define how they interact with each other. I think the example on one of the documents or web pages that I provide at the end of the slides, it actually gives you an example of adding an explosion. So when two objects collide, one of them will explode. Now, the last one, which is not really necessary or used often, but can be vital to a project, is ammo constraint. You can think of this as like a binding attribute. So this will bind physics bodies to each other. You can add hinges, and just like in this example, you can add a type of spring. So you could have a box and then another box and then add a spring between them. And then when you start the scene, it'll bounce up and down like a spring. All right, so here's a few examples. So this is a box that is static. So what does that mean? So an ammo body that is defined as type static means that it will never move, no matter what. And it's still a physics body, but it won't move. It won't even be affected by gravity. It'll just stay in midair. And even when you throw an object at it, it'll just bounce off. But the ammo body that is static will just stay there. And you'll notice that we defined our ammo shape as box. The ammo shapes are very similar to the primitives. So we have our box, our cylinder, our cone, and the ammo shape types are, they have one for each of those. So you can add a type box or a cylinder or a cone or many more. So this is a dynamic object. So this is where it gets a little bit more fun. These objects actually move. So when you define it as dynamic, they can be thrown, they can be affected by gravity as well. So if you have an object that is dynamic, you want to make sure they have something static below it, like a large plane that's static. Otherwise, it'll just keep falling and falling and falling forever. And yeah, again, same thing. Since we're using a primitive of a entity called a sphere, we're just going to make the ammo shaped sphere. All right. And again, this is where it gets a little more interesting. So the other type of physics body that you can have is kinematic. So kinematic is a special type of static body that actually moves. So you can add a velocity attribute to it. And in this case, it's just moving 1 unit of speed in the x-axis and 2 units of speed in the z-axis. And it'll just keep moving like that forever. And even if a dynamic body is thrown at it or something falls onto it, it'll just keep moving. It won't get affected by it. So essentially, yeah, it's just a static body that just keeps moving. And the last thing here that's interesting is if you set the ammo shape type to hull, it basically works like a shrink wrap. So the shape that comes out of this is what happens. Basically, it's like you take shrink wrap and you put it around an object and you just kind of conform it to that. So it's kind of like an automatic shape creator for your ammo shape to define the shape that's used for your collisions. All right, and then here's a quick example, an actual A-frame HTML file that you can put into your browser. And it's just a simple plane and 2 boxes that the 2 boxes are dynamic, so they fall to gravity. And the plane below them is static, so it doesn't move. And here are some more resources and documentation. I know the examples I chose here in the slides were pretty simple, but I didn't want to make the video too long. So of course, what you can do is you can go to the ammo.js documentation and they tell you and give you all the different attributes that you can change and define yourself. Like with the ammo constraint, like what kind of ammo constraints are there? So you can actually do a spring or a hinge or whatever. And then a really good website I found for examples was this one. And it's very simple. It just gives you a bunch of different examples, like adding your own JavaScript code to define what happens on a collision or when a collision ends, etc. So yeah, so that's about it for physics and collisions. If you have any questions, just let me know. And yeah, and if anything, if you get stuck on the activity too, just look at the documentation and the examples and that might help. But if not, then again, just reach out to me. So yeah, all right, thanks for watching.